Okay, let's go ahead and grab on that one. Okay, so chapter, like I said, guys, chapter 1 was about the nature of light. I know there's a lot of stuff, Aaron, my friend. I promise you, it will be PDF that I'll put on the network. So everybody understand, guys. If you like my summary, it's all I just summarized the chapter. There will be PDF and put in the network. Can I have thumbs up, Chad? So, um, okay. So if you guys remember, chapter 1 talked about the nature of light, visible light, invisible light. Then we went to chapter 2, if you guys remember. Chapter 2 talked about the different type of lamps that we use. And we talked about the arc lamps and the non-arc lamps, right? Incandescent lamps and fluorescent lamps, high intensity discharge, low intensity discharge, the arc lamps. And we talked about the ballast, controlling them and so forth. Talked about a little bit of LED lights and the efficiency or efficacy of the lights. This chapter takes it to the next level, guys. We talk about luminaires. Fixtures, lighting fixture, right above your head, Jeff. You are dealing with a lighting fixture. This is not the first time you guys heard about luminaires. You have already specified luminaires for me in visual, right? Can I have thumbs up, Chad? We specified luminaires when you drop these luminaires. This is just summarizing what a luminaire is. Okay, when it comes to luminaires, there are six things that comes with a luminaire, right above your head. Here, look at that one above your head. If you look at the first one, guys, is the housing. Everybody knows what the housing. If you take these diffusers and you take the lamps, you have the frame where the lamps are going to be sitting. That's called the housing. Why do we need housing for the fixture? Can you put just a lamp? Imagine putting a lamp like this and sticking two wires to it. Do you think you're going to get light? Yes, you will get light. If you grab an incandescent lamp and you put the wire hot here and the ground here to it, just tie them with tape or something, it will give you good light, right? It will lit. What's the problem with this? Not safe, not efficient, not convenient. There's a whole lot of things. Doesn't meet the code. So the smarter than Chad decided to put these lamps that we talked about yesterday in a big housing to protect them. So housing is metallic housing for protection purposes only, protection and safety, to protect the lamps and the associated equipment to the lamps. Any question about the housing, guys? Everybody knows what the housing? Then right underneath the housing, there's reflectors. If you open this, there's first the frame, and second, there's that metallic, shiny reflector that they put there. Anybody can guess why they put a reflector inside the housing? Yeah, direct the light to the location where you want it to do. Because the light, guys, if you put a lamp like this, it's going to shoot light up and light down. Do you really want to lit the ceiling? No, we want to lit the ground, the floor. So in order to direct the light down, the smarter than Chad, they put some reflector, shiny surface that reflect the light directly where the light down where the light wants to go. So direct the light and reflect it to the location. Any question about the reflector? So we have a housing, we have a reflector. Then we have a diffuser. Diffuser or louvers. Diffusers. Whom am I going to pick on? Adam, right above your head. Do you see that diffusers? Now, what's the reason why we have a diffuser? Anybody can guess? Why do we have the? Why can't we just look at the lamps? Give Ryan like to look at the lamps. Did you tell you that? The what? Hard on the eyes. Very good point. So when it comes to the diffusers, guys, the reason why we do diffuser like this is really two reasons. Number one, distribute the light. Instead of, if you look at it right now, it's distributed better distribution of the light. It will give you a better average in your room. And number two is to increase the comfort probability level, which makes it easier on the eye so you can't look at the lamp. Can I have thumbs up, Chad? So distribute the light, right? So distribute the light evenly so you can get a better average and make it easier for you and I to look at the light without hurting our eyes, right? So that's your diffuser. Diffuser. What the louvers? Do you guys remember the louvers cells? They look like this, cells, little cells. The same thing. Distribute the light. Either diffusers like that's one above your head, or louvers. They look like this. You guys have seen them. Right here, it looks something like this. Right? All these cells, and we're specifying them, right? The job of these is to hide the lamp so you can feel better underneath the light, number one. Number two, distribute the light evenly so your average that you were calculating with your friend Chad Kennedy is better. Morning, Joe. Any questions, guys, about diffusers and louvers? Can I have thumbs up for diffuser and louvers? Cool. Okay, then we move now up to this point, 1, 2, 3, guys. It's meaningless. We don't have a source of light, right? We have a housing, we have a reflector, and we have diffuser and louvers. But where's the source of light? Now we throw a lamp. Inside these three, we put a lamp right in them, right? Okay, what type of lamp? We can have incandescent lamp, fluorescent lamp, high intensity discharge, LEDs, or induction. You guys remember yesterday? Chapter 2 talked about the sources of light. You can throw in any fixture, almost any source of light, almost, right? Can you have thumbs up, Chad? So inside the fixture, the low housing, behind the reflectors, underneath the reflectors, and above the diffusers, you throw what? A lamp. The lamp can be fluorescent, incandescent, fluorescent, high intensity discharge, induction, or LEDs. Can I have thumbs up, Chad? And yesterday, the one that above your head is obviously fluorescent lights. Okay, so this is a lamp. The fourth part of a fixture is a ballast. Not all fixtures need a ballast. Most of them do. So ballast, two reasons for having a ballast. Anybody can do the two reasons for having a ballast? Why do we have a ballast? Boost the voltage so high to start the arc, and choke the current low enough so the circuit breaker doesn't trip to maintain the arc. Two reasons. You boost the voltage in order to start the arc. Now we're arcing. If you don't reduce, when you arc, there's high current. If you don't reduce that high current, guess what is going to happen to your circuit breaker? Trips. It's going to think it's a short circuit, right? So after you boost the voltage, we start in the arc. The arc is start to maintain and sustain the arc. The current start going through the coil develop resistance, and it choke the current and bring it down to the level of the fixture. Cool? Can I have thumbs up, Chad? So you have start the arc and maintain the arc. Start and maintain the arc by choking the current. Can I have thumbs up, Chad? Where do we need a ballast? We need it for all arc fixtures. What are arc fixtures? Fluorescent fixtures and high intensity discharge like mercury, metal halide, or high pressure sodium. These are need a ballast. When it comes to incandescent, no ballast. When it comes to LED, do I need a ballast for LED light? No. What do you need though? A driver. What's a driver? Takes AC to DC, 120 or 277 or 480. It brings it down to 24 volt DC and dump it across the diode so they can illuminate. So you still have a driver. Any question, guys, about the ballast? And I should also add a driver, ballast or driver, because of the LEDs. So probably here is also driver. Any question about the ballast or the driver? Can I have thumbs up, Chair? We fully understand that. Cool. That's all what we're going. Then, now we did all this. Then we need something to connect the power to it. We call it power connection. That's a little tiny box, part of the fixture where you connect your power, right? There, you guys, gentlemen, you need to bring your knockout in that fixture. There's a little box where you can stick your. Most of them have a little box. Not all of them. Some of them in the frame have a little box where you can tie the power to it. So we have a power connection box as part of the frame or separate inside the frame. Can I have thumbs up, Chad? What does that box do? Circuiting. You bring the circuit to that fixture. Any comments, any questions? Any comments, any questions? This is a fixture. That's what the chapter is all about. Fixture. Does that make sense? Easy, bad, ugly? So please read it. A couple of things. So these are what I want you guys to understand, these 6 things. Then there's two concepts I would like you to understand. Concept number 1 is CU, coefficient of utilization. Concept number 2, glare. The glare. Now look at this fixture. You said that one. The reason why we have a diffuser or a louver is to cut on the glare. Because if, I don't know about you guys, but have you ever, if you try to look into the sun, do you feel comfortable? If you do, then you're a weirdo. Right? Say it, but I mean, it'll hurt your eyes. Same thing. If you look at, even look at it right now, it hurts your eyes if you look for a long time on the lighting source. In order for us to feel comfortable under the light, the artificial light, we need to hide the lamps, period. If you hide the lamps, and if you can't see the lamp, direct see the lamp, then you feel much comfortable. Like these. Diffusers, great. You can look right into the source of the light without hurting your eyes. Take these down and look at the bulb itself. It will hurt your eyes more. Cool? So cut on the glare. To cut on the glare, we use diffusers and louvers. That's method of cutting on the glare. Can I have thumbs up, Chad? cutting on the glare, diffuser louvers. And when you cut on the glare, it makes you and I feel comfortable under the light, which is, that's a goal. Then there's also a concept called coefficient of utilization. Coefficient of utilization, the way they construct the fixture, guys, and the way they mount it in the room will decide how efficient the fixture will be. So remember the coefficient of utilization. Every fixture has a CU, coefficient of utilization, that decided how efficient the fixture will be based on the housing, the diffusers, the lamps, the mounting height, and the reflection from the walls, ceilings, and floor. So that has to do with when you calculate the foot candle, it affects your calculation of foot candle. Any question, guys, about these before I move into another? So that's basically your fixture. The second thing in this chapter, guys, is application. Now we know what our electrical fixture is. Now we're going to do application. Where do you put an electrical fixture? Take this, application. The first thing you're going to ask yourself when you have a fixture, is it inside dry location or is it outside wet location, right? Is it dry location or wet location? Wet, damp, or dry, right? So can I take this fixture that's listed and approved, listed, and go put it outside, right above your head? No. What's wrong with it? It's listed by UL, listed for indoor use. You put it outside, you have to have a fixture that's listed for outside. Can I have thumbs up, Chad? Because we'll have discussion and equipment. Next, so inside, outside. Next, so we did first the major decision, is it going to be inside or outside? That's a major decision for the fixture or any electrical equipment, guys, not just fixtures. The second major decision is hazardous location. Are we in a location where there's explosive gases and vapors that we need to pay attention to? Yes, you are moving completely into a different type of fixture. No, your only division is wet, damp, or dry. Can I have thumbs up, Chad, on that? Okay, now, hazardous location. Class 1, Div 1, or Div 2. Class 1, Div 1, 2 is flammable gases and vapors. Are you in a gas station? Are you putting a light inside the tank, the gas tank? Right? Is this the situation? Do we have Class 1, Div 1 location? Do we have flammable gases and vapors? We'll talk about this later, guys. If you do, then your fixture has to be explosion-proof fixture done. That will cost you probably 10 times more to buy this one. Explosion proof, it will cost you probably 10 times more than what it costs you to buy it right like this. You see why it's important? Explosion proof fixture. So you have to ask yourself, is it class 1, div 1 and 2? Is it class 2, div 1 and 2? Or is it class 3, div 1 and 2? Class 1, guys, flammable gases. Class 2, ignitable fibers. Ignitable fibers is class 3, combustible dust. So if flammable gases, class 1, combustible dust, class 2, flammable fibers is class 3. Obviously, the worst is what? Class 1, gas. Gas and fluid that can ignite. Gasoline and all this good stuff. So these are the 3 classified location by the NEC code book you have to pay attention to when you put your fixture. Can I have thumbs up, Chad? Yes, then AD, what do you call it? Yeah, there's fixtures. There's fixtures that you have to put. You're absolutely right. If it's a food processing, you have to buy a special fixture, globe for the fixture that protects it from easy to clean and so forth. For food processing, yeah. If you put in a food processing, you're absolutely right. There's another specialty for food processing. You're absolutely right. But we're talking about kind of the big picture here, but there's also, there's also a little bit more deeper as you dig. These are kind of the big picture is dry, wet, and hazardous. Under the dry, there's a few locations where you have to pay attention to. For example, you go to a museum. You can't put any fixture in a museum. It make things look nicer and beauty and so forth. But we're just talking about the general application here. Good point though, Joe. Any question, guys, about the application? We know inside, outside. We know hazardous location. The second thing I want to talk about is voltage. When you have a fixture, you guys were looking at the fixture's catalog number yesterday, and you were specifying a voltage. The best voltage that a lot of engineers like is called multi. Anybody knows what a multi? Multi voltage means bring it on. 120, 208, 277, 480, or 600. Bring it on. If you specify a ballast with a multi voltage, meaning you can bring any voltage used in the US here. Okay? Same with universal, maybe different manufacturers. I think universal is the same, but multi-voltage or universal voltage means you can bring any voltage to this fixture. A lot of engineers, guys, like, huh?
They're usually 120 or 277. The lighting balance are.
Yes, but you can bring a ballast that burn at 120 or 208 or 277 or 480 or 600. 600 is not a whole lot used. If you have a they list what a multi is, guys. It gives you almost covers any voltage. All what you have to do just bring it and tie it, and the ballast will figure out the voltage difference. A lot of engineers like the multi voltage. Otherwise, when you guys look at the catalog yesterday, we're looking at a catalog. You have to specify, is the voltage 120 single phase? Is it 208 2 hots coming from phase A and B? Is it 277 single phase? Is it 480 2 hots coming from phase A and B or C and D? Or A and B or B and C, or is it 600? 600, they use them, guys, in tunnels and other applications. So that you have to decide this. Or if you put multi-voltage, your ballast can burn at any voltage. Can I have thumbs up, Chad, for the voltage specification that you need to do? So we move from the voltage. I would say this is the best. Is to have multi-voltage because it matches any voltage you want. Now, how do we decide the voltage? By the way, which is the most common? Let's just say which is the most common. The most common burning is you burn at 120 and you burn at 277. These are, I would say, 90% of your fixtures that you have. You're going to burn them either 120 in our case, our project, or 277. 480 becomes, guys, parking lot. Bigger lights. They can burn them at 480. Anybody knows what the advantage of burning lights at a higher voltage? Lower current, which means cheaper operation, less losses, which means lower voltage drop. You want to take 120 a half a mile from here to lit a light in the parking lot. Guess what's going to happen to that 120 at the end of the run if you don't put a bigger conductor? You're lucky if you can get 50 volts at the end of it. Do you think the light is going to lit if you give it 50 volt when it needs 120? No. So what do you need to do to compensate for the voltage drop? Bigger conductor. So, or better, higher voltage. That's why it's 277. A lot of commercial industrial building, guys, they burn their lights at 277. Why 277 is so convenient? First, it's low enough, safe enough, and high enough, that's high enough to be efficient and low enough to be safe compared to the 480 and the 600. Okay, so that's, if you don't know and you want to burn a light, you always do option 120 or 277, but be aware that they burn them at other voltages too. Watts, you can buy from 5 watts, and I just threw this 5 watts there, all the way to thousands of watts. I threw here 3,000, guys, but you can go higher than that. You can get floodlights that can give you 5K, one fixture, throw lights. So from 5 watts all the way to 3,000 volts, 5 or 3K in this case. Your pick. Most of the time, if I'm to throw a number, most of the time you guys are dealing with close to, in an indoor, close to 100 volt amp, like these, 100 volt amp. And outdoor, you're dealing close to 250. Can I have thumbs up, Chad? If you're outdoor, start with 250 volt amp. If you're indoor, you start with 100, around 100. That's typically what we do indoor, outdoor, typical application. Knowing that we can go much higher than that, right? Okay, so lumens. Now, we talked about the voltage, we'll talk about the lumens. What the heck is a lumens? When they manufacture that fixture right above your head, when they start the arc and they treat the arc with the phosphorus material inside, the manufacturer tests these to get you how many lumens, the unit of light is lumens, how many lumens this arc with the phosphorus, with the type of tube that you're using, is it T5 or T8 or T12, this test them and give them a value called the lumen value. Your options are 3,000, there's 3,000, I think 4,000, 5,000 lumens. The higher the lumens, anybody can tell me the more light you can get out of the same lamp. Can I have thumbs up, Chad? Your start point will be 3,000. Almost always, you start 3,000, then you can go 3, 4. The higher the lumens, the more bright the fixture would be. What's the problem with more bright? It hurts the eye sometimes. So you have to kind of find the balance between high lumen fixtures versus low lumen fixtures. Okay. So here's a 3,000 all the way to 6,000, and I claim if floodlights can give you guys 10,000 lumens. These are just typical 3 to 6,000, but you can get tens of thousands of lumens from a big floodlight for stadium and so forth. Any question about the lumens, the amount of light that you can get? I talked about circuiting, guys. You can circuit. Here's how you can set. Typically, this is how you circuit your lights. This is face-to-face circuiting. So face-to-face circuiting. If I want to burn, these are 480. Here's my 480 volt. I bring phase A and phase B to the first fixture. Phase B, phase A, B, phase B and C to the second fixture, and phase A and C to the third fixture. Can you guys see it's like a three-phase connection? Three fixtures, three-phase connection. That's typical for high, 480. So they're burning at 480. Or I can bring 120. In this case, the way I'm showing it here, this is how you wire with 480. Two phases going to the fixture, right? Typically, you don't do this indoor, outdoor, parking lot common. Okay, so we talked about this one. The second thing I want to talk about, guys, is the ambient temperature. Fixtures, most fixtures in Minnesota, we appreciate that one. Most fixtures are rated to operate at -20 all the way to +50, and these are Celsius, right? These are hot and very cold, right? So most of them. But the good application, there are good application for both of them. For example, fluorescent is not a good application in Minnesota. We get cold. It's not efficient to put it outside, inside, right? High intensity discharge is a great application for outdoor in Minnesota. But typically they are rated between these two, plus or minus, -20 all the way to 50 Celsius, ambient temperature. That's where we give you the convenience. There's another concept called VCP. You have to understand this VCP. The way they calculate the VCP is visual comfort probability. This is how they come up with this number. They what do you call it? They pay a group of people, guys, the manufacturers. How many of us we have? Let's say we're 10 of us. We get paid to go sit under this light for a couple of hours. And then after you sit under these lights to do a task, they give you a survey. And you fill the survey, and you say, how do you feel sitting under this light? Give from 0, meaning I feel miserable. I was about to punch my friend in the face because I'm so miserable. And to 1, I feel happy. It's so beautiful, nice. It makes me comfortable. That's 100. 0, miserable. 100 is happy, right? So then they rate these fixtures based on how people feel underneath them. They give them a value, a percentage. 0 means very uncomfortable, and 100 very comfortable. I feel comfortable, statistically speaking. So each fixture will be assigned a value. Now, do you think you want to put a fixture that people feel very uncomfortable underneath it? No. For example, if you take the louvers here, the lenses, and put the people underneath it, most likely it will reduce their comfort level. It will reduce their comfort level. Does that make sense? So please remember the VCP. I guarantee you this will be in your test too. What is the VCP? Visual comfort probability. How comfortable I feel underneath it. What does the 0 means? Very uncomfortable. What's the 100 means? Very comfortable. In between, typically they are in between in the 80s and the 70s and the 90s, the values. Can I have thumbs up, guys, about the VCP? What the VCP is? Cool. Then the last thing, I don't know if you guys can read my handwriting, but believe it or not, this word is mounting. When you have a fixture, you need to mount the fixture, right? How do we mount the fixture? Kerry, my friend, you were throwing all your fixtures in our project, and you were asking me, Chad, is it recessed? Recessed like these, right? Is it suspended? First, recessed, suspended, surface mounted, wall mounted, right? Either surface mounted, you surface mount it, or recess it in the ceiling, right? Or suspend it from the ceiling. So these are your options. You have recessed, you have surface mounted, or suspended or hung. You hang it. Any question, guys, about these methods for the most part? Typically in a commercial building, almost always recessed. You have a false ceiling like one above your head, and they're all recessed in the ceiling. In an area where you want the people to feel comfortable, they use direct, indirect light, and they suspend them down. Suspend them down so they can shoot light up. Can you guys look at the ceiling? Is the ceiling lit good? Is the ceiling look dark to you? So if you suspend this fixture and have direct, indirect light, It will shoot light at the ceiling, so the ceiling will look exactly like the walls, really well lit. Who cares? Some people feel comfortable in this environment when the ceiling is really lit, the walls are lit, and the floor are lit. They feel comfortable. Remember, we're in the business of serving the public, right? So they can pay us. Anybody's not in the business of serving the public? No? Oops. Oh! Okay. Plead the fifth here. All right, so your job is to make the customers happy, guys, right? That's our job, if we're going to stay in business. Any question about the mounting? Cool. So these are the things that I summarized for you. So these are my mounting. Let's go down into, okay, now the second thing, part of all this mess that you guys are going to be reading, and there's some information I jumped over. Please read them. I picked the most important things. There's something called the isofoot candle curves. Isofoot candle curve. Does these curves look familiar to you? Isn't that what we did with visual? Thanks God for visual, all these softwares. Isofoot candle curve. Here's how it works. Look at this. I have a metal halide fixture, right? Look at this, metal halide fixture. And I have a 30 foot pole. And I went and I did the calculation based on 30 foot on this side, 30 foot and this side, and basically, if you imagine a light in the middle of a parking lot, 30 feet pole, and you're going to do the calculation on every point, a circle of 30 feet around that light. No, it's not directed, it's just a globe. You know, it shoots lights everywhere, in every direction. So the smarter than chat guys, if you put a light there, no walls, nothing, it will create something called isofoot candle curve. What the heck is an isofoot candle curve? Isofoot candle curve is a curve, these blue curves, a curve that has all the foot candle points, the same foot candle points around the fixture will be connected with one curve that's called isofoot candle curve. For example, this curve here is 5, here's my fixture, right? Here's my fixture. And I went right into here, right? The first curve connects all the points around the fixture. They have 5 foot candle. The second curve, 2.5. The third curve, 0.5. The fourth curve, 0.25. And you keep going all the way around it. You guys expect the further you move away from the fixture, the less the foot candle would be, right? The closer you get away to the fixture, what happened? The more foot candle you do. That's exactly what you guys did with me in the parking lot. When we did the parking lot, remember that curve that you grabbed? Like this, and you start dropping these curves and overlap them. That's exactly what you're doing. The only thing, Aaron, you didn't do is you only activated the 0.5. Remember when you pick the 0.5? If you went and picked the 0.25 and a couple of other points, it will draw a line exactly like this. Can I have a thumbs up, Chad? We understand what an isofoot candle curve is. Isofoot candle curve. Okay, so that's your isofoot candle curve. You put a fixture right here and it project all the lights around it. Project all the lights around it. There's something called distance to mounting height. Joe, my friend, look at the height of this pole is 30 feet. The distance is 30. What's the ratio distance to height? 1 to 1. Typically, they shoot 1 to 1. If you don't know how to place your fixtures, Kerry, my friend, start with the point 1 to 1. So you put a fixture right here, right? And 1 to 1 ratio to get you a good application. If it's a 30 foot, you move 30 feet from it, and you put, well, that will be the end of the influence of this fixture. 30 feet, 30 feet, 30 feet, 30 feet in every direction, right? Now what do you do then? You move over here and you put another fixture, and that will give you another 30 foot here. So between the two fixtures will be 30 plus 30 is what? 60 feet between the fixtures. We'll talk about this one, guys, in a second. But this is the distance mounting height. In my case here, the mounting height is 30 to 30, and that will give you a ratio of what? 1, basically 1. 1 to 1, mounting height to distance. The further the mounting height to the distance, guys, away from each other, the less light you're going to get. You're going to get shade between the lights. When we do visual, thanks God. That's why, remember, guys, when you grab the fixture, it has the isofoot candle curve like this. Here's fixture 1, fixture 2. What did I tell you? You grab the influence and you overlap them. See what remember how we overlap them like this? Why do you think we overlap them? So we can get a better distribution. If you just put them this way, this area in between will be very dark. So you grab them and slightly overlap them. You will guarantee that the area between them it will be as good as an area underneath them. Cool. Can I have thumbs up, Cheb? We understand what an isofoot candle curve is. Yes, no? Okay, it's not Monday, guys. We can't blame Monday on that. Okay, so that's my isofoot candle curve that you guys are going to be dealing with. The last thing is photometric characteristic curve. Photometric characteristic curve. I want you guys to look at this boy that's called photometric characteristic curve. You know what the manufacturers do, and I witnessed that myself. Holophane. We went to into Ohio one time, a couple of years ago, like 6 years ago, Gary and I, to Holophane manufacturers of fixtures. What they do, guys, is they grab a fixture. They have a lab. Every time they design a fixture, they put the fixture in the corner of the lab, and they have sensors everywhere in the room designed to test the fixtures. They have just imagine here, guys, I'm a new fixture, right, sitting right here, shining on these walls, and every single point, foot by foot, around all the walls and the ceiling, have sensors that sense the lumens, measure the lumens. Can you imagine that? Measure the lumens all around that room. And then they draw something called photometric characteristic curve. That's your IES file that you guys picked. When you picked an IES file in Visual, that's what you did. You picked a photometric characteristic curve, right? So here's how it goes. Here's my fixture here. These are the angles around it. I put my 80 here, 90, 0, 80, 90. So that would be what? 270. I flipped it. I flipped the parameters. This fixture can only shoot this way. So I have directed fixture, right? It doesn't go back. So it will shoot the light this way. Like I'm the fixture, I'm shooting the light this way, right? And they have sensors all over here to sense on every angle, to sense and measure and calculate the lumen. So let's look at right at 45. At this point, my lumen is 1203. Now remember, this came from a sensor that's sitting there and picked this value and recorded. Another sensor at angle 150, I have a sensor that picked 805. And they record all these values for every single fixture that they have. All these values will be recorded for every single fixture that they have. And that will create something called photometric characteristic curve. Thanks God we don't use them too much. These are all loaded by the IES file that you guys loaded. All this info is loaded. So when you guys grab a fixture and you do the calculation, excuse me, the software does the calculation in that, it's pulling the IES file. The IES file is pulling the photometric curve, a characteristic curve for every single fixture manufactured by certain manufacturer. Can you have thumbs up, Chad? So then they draw a curve like this, and this will be the area that this fixture will cover. You guys remember? This is similar to the one that we did in the parking lot too. How that little curve, so they draw a little curve that represent the best performance for this fixture. Anything inside that curve will be really lit good inside this fixture. Can I have thumbs up, Chad, that we understand that curve? We're going to be using these curves just a little bit for calculation by hand. Thanks God for the software. When you load your IES file, it will load all this information. This particular info was coming for 150 watt high pressure sodium. Every fixture at every watt, at every reflector, at every housing will have a value like this. Will have a value like this. Any comments, any questions, guys, about this? Any comments, any questions? Comments, questions, no? So that's basically what this is. The last thing I want you guys to do is do me a favor, please. Can you go, because these are important. Can you go to page 34? Go to page 34 in your book. I should take a picture of this. Page 34. Can you guys see way at the bottom? Way at the bottom. These are very, very important distribution. They're called light distribution patterns. The patterns that you have for light distribution. Okay, let's start. You don't have to memorize them, but be aware of them. The first one, direct. Joe, my friend, look at that above your head. That's called a direct light. What's a direct light? It shoots top to bottom. So the way they define direct, if 90 to 100% of the light that comes out of that fixture hits your head. That's how they define it. Can you guys see what direct is? Sometimes 0 to 10% goes up. Can I have thumbs up, chat, for direct? 90% of what you guys designed for is direct light. Cool. These are all the direct lights, all the surface mounted and recessed lights, all of them are direct.
I have a lot of them indirect. So,
We're coming to, but if they are surface mounted or recessed, they're all direct. Why? Because if it's indirect, where it's going to light is going to go.
well, it's what the reflector's on me, though. I see a lot of 2x4s like this.
But they're suspended then.
No, they're, you know,
And they're shooting.
prismatic. They shoot out and they reflect off.
Yeah, they're reflected with the reflected. Absolutely, yeah. But I'm talking about the whole fixture. If you want to have a fixture, direct and direct, you have to lower the fixture so it can shoot up. You do the indirect inside the fixture. I see what you mean. Inside the fixture, you throw it up and it shoots it down through the. But the indirect, really, you throw it to the ceiling and the ceiling will shoot it down. Okay, that's where the indirect is. Okay, let's go to semi-direct. Semi-direct. I think this is probably semi-direct what you're talking about. Semi-direct, guys, up to between 60 to 90% will be shooting down, and 10 to 40% will be shooting up. In order to get the semi-direct, you almost have to suspend the fixture, right? You have to suspend the fixture slightly, or you have to do like you did. The fixture will be shooting up and down, but most likely it has to be suspended because you depend on the ceiling to shoot, to push the light down. So these are suspended. Can I have thumbs up, Chad? Semi-direct. Let's go to general diffuser. General diffuser, I'm going to go pick on my friend Jamie's head here. Imagine Jamie's head is a light sitting right there, no reflectors around it, and it shoots light all around you, right? Imagine this is a light here, and there's no diffuser, and the light goes in every direction, up, down, in between. Can I have thumbs up, Chad? Where would you use this when you guys walk to Dunwoody? You see these little lights that's sitting at the top of the pole, right at the top of the pole. They're not directed like this. They're just sitting at the top of the pole. These are general lighting. It diffuses the light all around it in a circle. Can I have thumbs up, Chad? Goes up, down, and in between. That's your general diffusers. Direct, indirect. Direct, indirect. These are the suspended ones that you guys did for me. Remember the office? The what do you call it? Yeah, the office. In our project, when you guys picked these direct, indirect light, Gotham light, they shoot most likely 50% up, 50% down, or 60% up, 40% down, or vice versa. So they shoot the light up to the ceiling, it bounces off the ceiling, comes back. Who cares? It makes huggy feeling people like Jeff, for example, feel good when they walk into the room. The room is well lit. The ceiling is really lit. So with this fixture, you have to have what type of support? It has to be suspended. Okay, can I have thumbs up, Chad? With direct and direct, that's you guys are having a direct and direct light. So it could be 50-50 or 40-60, up, down. Typically, guys, 60% down and 40% up. Semi-indirect. Oops, semi-indirect, guys. This is up to, what did they say? They say 60 to 90% shoots all the way up and only 10 to 40% down. Most of the light goes up, bounce off the ceiling. Now you better have a ceiling that reflects that light, and it shoots it all the way down. Okay, so I would say for this one, probably 90% of the light goes up and 10% of the light goes down. Okay, the last one is indirect light. This is completely indirect. So what they do, guys, they put the bulb like this, cover underneath it, and they put your bulb right here, and all the lights, and they suspend it, and all the lights that comes out of this bulb hits the reflector here, and it shoots all the way to the ceiling. That off the ceiling goes down. Who cares? The indirect ones, guys, is a lot of people love them because first, you don't see the lamp, so you feel really good underneath it. Comfort probability level is high. Second, it lit the ceiling, so people don't feel that the ceiling is dark. Like, I don't know if you guys look at the ceiling compared to the floor is dark. So it makes people feel better. Who cares? People are productive under this type of light. So a lot of the companies, Best Buy, if you guys look at their campus in Richfield, Best Buy and everybody else, they go into direct and direct light or semi-direct, where they shoot most of the light up and it's reflected off the ceiling down. People look really nice. They not look nice, they feel good underneath these lights. Any question, guys, about these patterns? I can't emphasize one thing. Unless the fixture is direct, you have to suspend it. Right? Direct fixtures have to be surface mounted or recessed. Anything other than direct, it has to be suspended. The general one, it's mounted and there's no reflectors around it. You can't put a general one right here because it has to lit all around it. Can you have thumbs up, Chad? We fully understand that. So that's basically what this chapter is all about. Any comment? Any questions? Any comments? Any questions? No? Should we have 5 minutes? And I'm going to go over chapter 4, some calculation. We're going to do some calculation. Okay, thank you, guys.